So chapter 13 is about alternative energy, renewable energy. And the book breaks up the energy forms first into direct solar energy, which would include passive and active solar power. And then it goes into indirect solar energy, and that's things that are powered indirectly through the sun. So wind, how the currents are based on the temperature, which comes from solar radiation. Biomass energy, which is powered by the sun, and then hydropower, which some types are powered indirectly by the sun and some are powered by gravity. So that could go into either the indirect or the other renewable energy. And then the book talks about towards the end, geothermal energy, tidal power, and hydrogen fuel cells. Direct solar energy is available all year long, although you might have different amounts at different latitude or different, varying degrees away from the equator. In some places you'll have more in the summer. And, on the south of the equator, the seasons are reversed. And obviously you get more sun at different times of day and cloud cover. And this map of the U.S. shows you where you get the most solar radiation. So the most here is in the southwest, which I don't think is surprising since we know these are traditionally very hot states with desert areas. And then the second amount would be down here through our subtropical region here. And the least amounts would be up here in northern Washington state, parts of northern Oregon, and the northeast of the United States. Passive solar energy is when you use the sun's energy to either distribute heat or to reduce the heating of your home. You might collect heat, but you're not actually using like a solar panel cell. So passive solar energy is when you're designing a home to enhance the power, use the power of the sun to help keep it warm. So in the northern hemisphere, south-facing windows are going to help keep your house warm in the winter. While down here in Florida, where it's hot all year, we would probably not want to have a lot of southern exposure windows because it would make our home hotter. So passive solar energy is really about using the design of your home. Having your home well insulated can both can help absorb some of the heat from the sun, especially up north where you want to keep it warm. Having vents in attics and having overhangs or solar sun spaces to make your home warmer if you're in a northern hemisphere. So here you've got the southern facing windows that lets the sunlight in. The double panes would reduce heat loss, but this would not be a great design plan for Florida. You want to have warm air here. You want to have heat vents in the attic so you can let some hot heat out in the summer. You want it to be insulated because that kind of helps keep either heat in or the cool in the summer. Thick adobe or stone walls can help store the heat in the winter if you're in a cold area. So passive solar power is mostly about good design. A solar sun space is an area, so you're going to have southern facing glass windows here. And then you would have water-filled drums that usually are black because they'll store more heat. And they'll store heat from the sun during the day, and at night they would help heat your home. And again, you'd have a cooling vent there for in the summer. So if you lived up north, this is a great way to reduce your heating bill and to use solar energy in a passive way. Active solar energy is going to be using either solar panels, near solar collecting devices to heat up salts, or this hot water solar heater, essentially. So this right here is when you have a solar collector and you've got tubes and coils of water, and as the heat hits it, it's going to heat up the water. It's going to move through a pump to a heat exchanger, and it's going to help distribute hot water through your home. 8% of the energy in the U.S. is used to heat water. So if you use this instead of a hot water heater, like a gas or electric powered hot water heater, when you took your showers, you would, be saving some electricity. A solar thermal electric generator makes electricity. The sun is concentrated either by using mirrors or lenses, and it's going to heat a fluid-filled pipe, which will drive a Stirling energy or engine. Or instead of a fluid-filled pipe, it could also heat up salts not like the salt that we think of traditionally, like that would we use in our food, but it heats up salts that again store that heat, but it still then heats up a fluid-filled pipe. This is really efficient. It doesn't contribute to air pollution. There's no contribute to global warming. There's no contribution to acid precipitation, but it does take a lot of space in general. So here you've got your pipe with the fluid, in this case oil. You've got your sunlight, you've got the mirrors, and all of this is really concentrating it, kind of like a solar oven. If you've ever made a solar oven in school, or like we'll use one in a few weeks maybe when it's less rainy, but you're really just concentrating the thermal radiation from the sun. You're using it to heat up the oil here. There are some horrifying stories people tell about the potential for catching fire. So if you notice, there's not much growing around here. You don't have homes built right around it. And there have been a few stories about birds catching on fire. It would be very few, though. It would be a bird that was hanging out here long enough to really be concentrated in that heat. So it's not really a major con. It's a rare incident. But it does usually take a lot of land. You'll see kind of solar farms made out of these solar collecting devices, particularly in the Southwest. In Florida, we're most familiar with photovoltaic solar cells. And these are thin films usually, or sometimes a thin white wafer. And it's treated with certain metals. So it's going to generate electricity as it absorbs solar energy. It doesn't put out any greenhouse gases. There's very little maintenance needed. And you can use it on any scale. So if you're in Delray Beach, you'll see road signs that light up at night that collect solar panels. We have solar panels in a lot of road signs. You could power a whole building with it. A few years ago, the zoo in West Palm covered all of its parking shelters with solar cells, which is a great idea. It gives you a cooler place to keep your car during the day, and it gives you a great place to kind of make your own electricity. In the case of this solar cell here, what you have is phosphorus and boron, enhanced silicon, and then you've got your back contact. And really the sunlight's going to help move, the photons from the sunlight are going to help move electrons. And once those electrons move, they are going to generate a current. Because we know that electricity is just the movement of electrons. So instead of it being powered with a generator and a magnet, the photons from the sunlight hitting these different, this phosphorus and boron-rich silicon, those photons are going to excite the electrons, and that's going to generate the current. Solar cells can actually be cheaper in rural areas than running entire electrical grids, so it's a great way to incorporate renewable energy into developing areas or rural areas. And there has been so much, even since this book was published, which was about 10 years ago, so it's getting old. But they have shingles and roofing shingles. So here you can see the solar paneled shingles. They really kind of blend in. And if they had done the whole roof like that, you wouldn't be able to really even tell the difference. So you've got roofing shingles, you've got tiles. As we know, we saw earlier this year, the solar freaking roadways that were made to conduct electricity is on a trial basis. There are clear solar panels, so you could basically, instead of using regular glass, all of these windows here could be conducting electricity. And that really is going to change the tide for large commercial buildings. If you think about like a large glass building in a downtown area, all of those windows could be generating an electrical current. So there is lots of growth in solar power. Solar power has become much cheaper. It's rapidly becoming cheaper every single year. And we used to have all of the top 10 worldwide solar-powered research companies were all located in the U.S., and now we only have about 2 of the top 10 companies. But it's really an area of both innovation and a chance for us to really make money, because solar power and solar-powered cells are something that's really people across the world are interested in buying. So it's a great way for us to invest and use our innovation to, make a new industry. So right here, power sources are becoming competitive with traditional power sources. And if you look at the generating cost, cents per hour, hydropower 4 to 10 cents. Photovoltaics have dropped by at least half of this since our book was published. So your PV cells are dropping rapidly. Coal and natural gas and nuclear power in an older plant are still kind of cheaper. Wind power has actually dropped a little bit, and so the biggest growth areas in power are going to be wind and solar cells. And again, this cost has dropped by about half since this was published. Biomass is when you use plant materials like wood or crop waste or animal waste and use it as fuel. So it could be anything such as burning wood, burning charcoal, which is just burned wood, slowly burned, so it kind of gets that it gets hollow and has that black crust on it, and it burns slowly afterwards. If you're taking crop waste and you're making them into ethanol, that's still biomass. If you are taking animal waste and turning it into like a natural source of methane, that's biomass. Or if you're taking algae and you're turning it into biodiesel, that is also biomass energy. And that all comes indirectly from the sun. Wind energy is electrical mechanical energy obtained from surface air currents that's caused by the solar warming of air. And you guys made wind energy. You made turbines earlier this year. So, or at least most of you did. So as you know, in wind energy, the sun heats up the surface air that causes currents. When the wind moves, it moves a turbine, and that turbine is going to power a generator, and that generator is going to move magnets, and those magnets are going to move electrons, and the movement of electrons is electricity. And I have the hand generator that I run around the room with kind of obnoxiously when I talk about that. Hydropower is a form of renewable energy that's reliant on flowing or falling water to generate a mechanical energy or electricity. And if you're looking at water like falling down a mountain or downstream, it's not going to be indirectly powered by solar energy. But if you're looking at a water current, like in a river, that could be indirectly powered by the water heating up from the sun's energy. But if you're looking at like a waterfall, that's not indirect solar power. That's just gravity. And the same way it's going to happen. It's going to turn a turbine, which is going to move a generator. Generator has big magnets. Magnets move electrons, and the movement of electrons generates electricity. All right, and we'll go over the rest of it on the next section.